Starting, and we're live. Okay, it is Thursday, December 11th, 2014. This is DB Hangops. And today we are going to be talking about mixing metadata and data. This was something that Shlomi had requested probably about 2 months ago, and we just kind of kept punting. And so things like, having schema representing some data instead of metadata, and kind of how that works and how you deal with that. And also we're going to be going down the road of InnoDB compression. And this was something that John had asked about last time. How do you performance tune for it in MySQL 5.6? How is it different? What kind of metrics should you be aware of that are going to change? Just overall performance impact of it and things like that. So without further ado, let's kind of get going, get everyone introduced. My name's Jeffrey Anderson. I'm a DBA at Box. And let's go ahead and start with Daniel.
Hello, I'm Daniel. I'm a DBA at Snow.
Okay, Jeremy.
Jeremy Tinley, a DBA-ish type person for Etsy.
Okay, John.
I'm John Cesario, and I'm a DBA at Square.
Shlomi.
Hi, I'm Shlomi. I'm engineer at Booking.com at the Netherlands, newly arrived.
Yeah, Shlomi, your mic is like super, I barely hear you.
Okay.
But Shlomi is there. Trust us. Tim.
I'm Tim Callahan, and I'm an engineer at Tokutech.
Okay. So, yeah, without further ado, let's see if, Shlomi, do you have a better mic solution yet?
Can you hear me now better?
Oh, way better.
Okay, cool. So I'm Shlomi. I'm newly arrived at Booking.com at the Netherlands.
Cool. Okay, well, yeah, so anyways, the first topic, Shlomi, was metadata, mixing metadata and data. And I was hoping you could get this kind of started off and kind of lay some ground for what you were wondering about.
Okay, so it's something that's bothering me, and it has different levels or different aspects. So I'll just produce a couple. So we have data that is our rows and whatever business data you have, and there's the metadata, which is your tables and foreign keys, whatever. And then there's metadata, like users, privileges, who can access what, etc. And these are like on 3 different layers, and sometimes they get mixed, and they get mixed even if you don't want them to, because MySQL forces you to mix them. For example, the meta and metadata are mixed in view definitions and trigger definitions. So every view has an owner or a definer, as well as every trigger. There's the account that created the trigger, and the trigger acts on behalf, or can act on behalf of that account, right? So whenever you insert to a table and trigger is triggered as response, it can act on behalf of the user that created the trigger. Now, when you dump the schema of your data, or when you just dump your data, you don't necessarily want to know about the user accounts and stuff like that. And if you change an account and someone leaves the company, so it turns out that stuff that doesn't actually belong within your metadata is brought from outside and into your metadata. So it's like, what do you do? I mean, there's other examples as well, but the trigger example for me is something that's always bothered me. I create a trigger, and it's forever under my name, or be it root at localhost or whatever, and it's just stuck there, and it couples with the user identities, which is completely unrelated to the schema definition. So I'm wondering whether some of you have experienced stuff like this before, and if this bothers you, and what do you do? I can say what I do, but it bothers me just. So yeah. I kicked it off. Go ahead.
Yeah, I had the same kinds of issues with views, but just creating a view, and even when the security is not set to a definer, then you need to have a valid user account, and also a valid base tables below the view. That's shouldn't be necessary.
So sometimes I would export, I would do MySQL dump, just export a schema onto someone else's database, and it won't create because the account does not exist there. The account of the owner of the view or the trigger. It just bothers me because it shouldn't be dependent on something that is higher in the meta hierarchy.
Yeah, or check it at runtime, maybe.
That's actually an interesting just ramification of that, because I wasn't 100% sure about the problem with it, and it's partially because I don't really have any views or triggers in my systems. But yeah, if you have just having that user account tied to it and loading it into another server that doesn't have that account, like, I mean, so normally it would just fail on load, but like, Daniel, have you had problems where it does load successfully, but then fails to execute because the account's not there or something?
No, mostly it will work. Although if you delete the user, what do you expect to happen? Should the view be removed, or should it just fail and execute, or shouldn't it be allowed to remove the user? So many options.
That's really interesting. Well, the obvious answer is you should just create all of these as root, right? Everyone has a root account, right?
No, not everyone.
So my solution actually is to actually have a root account. There's always a root at localhost, but it is it's like disabled, so the password is encrypted in such a way that no one can log in as root. So it's like the MySQL user on the Linux system. No one can actually log in. You can just sue MySQL. You can only change root as MySQL, but you can't actually log in as user MySQL. The same goes for root localhost. It has an impossible password that no one can enter it. So that account always has to exist. But then again, that account has typically excessive privileges, and I wouldn't want to create like dozens of accounts that would migrate with the schema wherever it goes. That it should only have the limited set of privileges like insert update on some tables, etc. It seems like such an overhead whenever I create a trigger or a view to create the metadata for the trigger in the form of new accounts and stuff that would just migrate with me and walk me through wherever I go. It's not inside the table definitions. It's like when you dump your database, you don't dump the user privileges. You do if you also dump the MySQL system tables, but it just doesn't feel right? It's not part of your schema. It's not part of your data.
So I guess I'm actually curious, what's this look like on other products? Because I actually never even thought about this when I set up triggers and whatnot on Oracle. Like I never had to like consciously move them from one instance to another. Does anyone else have experience with how other products do this? I'm going to take that as a no. This feels like a great day for Mark Leith to be here, and he's not able to make it today.
I was just thinking the same thing. I was like, yeah, why is Mark not here to tell us like why this is the case, and like he probably has some interesting insights into the history of how this came to be and why it is still this way. I think what Shlomi's defined is generally what most people do is you create like a backend like service account sort of user, and then like perhaps you prefix the password with like an invalid character or something so you can't log in, and then you just define everything as that, right? And then but you have to remember to move it, and like he said, that doesn't come with when you dump the schema, which means that your schema is no longer a self-contained object or application or anything else. It's now dependent on the MySQL schema as well, and not just that, but the MySQL, like nobody's going to say no to dump the application schema and then to go back and dump just those rows from the MySQL.user table. Generally, if you're going to do that, you're going to do the whole thing, which means that if you want to transport it to someone else, say for example you do define as root, you may just nuke someone's root user account when you load that back in. That's painful. That's really painful. So what's the acceptable way forward? If we could tell MySQL development to just be like, do this way, what is the define invoker by default, maybe?
Yeah. So I thought it could work like the event scheduler. So the event scheduler runs as a system user, much like the replication thread. So you don't need to specify anyone in particular. It just runs as the MySQL user. It's the system.
Yep.
I think it would be nice to have such a thing that I don't want to care about privileges, owners. Just make it run. And so there's some nice tricks to do with SQL security equals definer or user. It's cool, but I don't necessarily want to have this.
Yeah. Also, if you create the trigger as a root at localhost, you need to have quite some privileges to be able to do that.
Yeah, that's definitely like one of the other things is you genuinely need to be the DBA or root level user of any system if you're going to transport it as a root or localhost. Having it set up. So when you talk about the event scheduler, Shlomi, is that the cron-like thing that's inside of MySQL that you're referring to?
Yeah,
okay.
Yeah. I tend to use it for lightweight missions, like injection of heartbeat or sudo gdad or just little commands, not something that is heavily reliable.
Yeah. So something else I was actually curious about. So when you have a MySQL schema, you can usually I don't know. I'm sure MySQL dump does this natively, but I haven't done it through there. But using Workbench, you can export kind of a vendor-independent schema so that you could export a MySQL schema and load it into Oracle or Postgres, for instance. How does that look when you do views then? Does it actually export them in some kind of standard way that could be loaded into these other systems? Does anyone know, actually? I have no idea. Hold on, let me sip my HBase mug the other way. There we go. I'll take that as a no. All right, I've got homework to do, I guess. But no, that's the other thought too. And doing something like you had suggested, Shlomi, around event schedule or something. Maybe that is the right answer and how you ultimately do it. Would people actually be opposed to maybe the right I'm going to put in quotes answer is actually when you kick out a schema, it automatically kicks out the user account with it somehow, or makes some loud noise about a user account, like, hey, this user account is the definer, make sure it's over there, something like that?
That's the catch-22. If you actually did automatically dump the user, you would have to make sure you aren't going to overwrite someone's user account on the other end, right?
Yeah, exactly.
Or modify their privileges out from under them. Like, that's not cool either. I think really just getting rid of changing the entire security model of events, triggers, and views in general is kind of what's needed, if you ask me. It needs to be redone and just abstracted out from the main user grants in general. Or like probably more appropriate would be to somehow make these objects more part of the actual application schema as opposed to like the MySQL.routines table or anything like that, right? That to me seems like the better way forward, because then that means we get closer to the idea that each schema is a self-contained application and saying can be moved around at will and whatnot, for better or for worse. But I don't know. Anybody else have any opinions on what the way forward is?
Personally, I've been actually staying away from views, triggers, just stored routines in general, at least until 5.7, just from what I saw at the last conference I went to. Mark was talking about all of the new instruments getting into performance schema around stored routines, and part of the reason was, it's hard to instrument them. A lot of engineers and other developers I've talked to, they wonder why we don't just have a stored procedure to execute some application logic. And the answer is, well, in SQL Server, yes, that's what you do normally. But with MySQL, the stored procedures are they're still a little weird. And the big one for us was instrumentation was just very difficult, or if not non-existent for it. And so our preference was always have the application be responsible for doing all that extra work.
Right.
But yeah, Shlomi, you work with like common schema, you build common schema to leverage these kind of facilities. So I imagine there's other things there too.
There's a beta, an alpha companion to common schema. It's called rdebug, which is an 85% complete debugger for stored routines, which does code injection into your stored procedures. it's pretty ugly. This is really the only known solution that, you know, some products use emulation, others like what RDebug do uses code injection. Neither actually model the exact explicit behavior of stored routines. It's ugly, and hopefully we'll see good stuff on stored routines by Oracle. Yeah, I would very much like to see that. Yeah, stored routines are typically very heavyweight and undesired in current implementation. They're really hard to debug. You know, you don't see them on Percona server. You might, but you typically just you don't see the slow logs generated by stored procedure. You just see the stored procedure. There's a lot of stuff that, you know, you can't see what's being done right now by the stored procedure at any given moment. It's like a black box in almost every sense. In terms of views, I use views quite a lot, especially Como Schema is a perfect example for that, because it's a utility schema which uses a lot of views. So it's pretty cool. There's quite a few handy tricks, but the general idea is that you always create the view as user root and set the SQL security equals user, and just, you know, let everyone deal with their own problems when they access the views. You know, I would just like it to be non-user related as much as possible, and let it figure out stuff like by itself.
Got it. And actually, Tim, I was curious just on the Toku side. I mean, I know you guys are more storage engine focused, but do you have any use cases around views, stored routines that you guys have had to address, and any, I don't know, maybe storage engine wise, but also up in this layer?
No, just bugs. We recently fixed a bug where triggers were overlocking. So certain trigger types, if you did an insert trigger, for example, we ended up locking the entire PK key range, which was a bad thing, but that's since been fixed.
Got it. Okay, yeah, so, go ahead.
I'm sorry. Some other stuff that relates to mixing of data and metadata. So, like, before I left my previous employer, Outbrain, I gave a series of lectures about SQL and how to do queries and table design. And some people would say, yeah, well, you're tweaking that query to play nicely with MySQL, but it's not generic. And if we ever migrate to another database server, so it's really bound to MySQL. And we argued a bit, and it turns out there's quite a few stuff that you're doing with your data and metadata that are completely bound to MySQL. So your partitioning is a metadata on your tables, yet it relies on your specific data. If you use federated tables, that's completely like servers and ports, hosts and ports and stuff like that. So there's a lot of stuff that is going on that is mixing your data with metadata. I guess it all boils down to you know, that's reality, and we want to get performance, so we sacrifice the beauty of the data. But it turns out that there's a lot of hidden spots where you're doing that and you don't even notice.
Yeah, I'd probably say anybody who's trying to keep their entire app generic enough to just drop in a new database has probably never actually attempted to do that before and doesn't realize how hard it actually is.
Yeah, I've actually met a few companies that migrated from MySQL to Oracle or from SQL Server to MySQL, and you know, it was months and months of migration, right? It's not, there's nothing like, no dump and reload would ever work magic.
Exactly. I mean, at best, there's some tools out there in the wild in someone's GitHub repo to help you translate your actual dumps or anything like that, but for the most part, the actual type of pattern of development for SQL Server, Oracle, MySQL, Postgres are also drastically different in how you kind of go about designing your application to turn the database into almost an embedded primitive within the app is just completely different. SQL Server, for example, is I doubt you talk to a SQL Server DBA, they would be shocked that everything isn't in a Sprock, right? Right, and probably very similar for Oracle stuff too, but the languages are different. And then Postgres is, I mean, you go with Postgres and some of the optimizer query stuff you write is going to be completely different than what you would do on Oracle, and MySQL obviously with its optimizer, you usually end up over-optimizing for MySQL's optimizer in specific because it tends to do some weird things occasionally. I wish like the idea that like someone could just plug in Hibernate and just be like, oh yeah, I can just drop any database I want in the back end. But once you get out of the gate and you actually launch a product, you quickly usually find that you are optimizing for the tool set you have, not for the one that not for all of them. It's just not time. It's not reasonable for time. So, but yeah, I would tend to agree with you completely on that, Shlomi. I've heard that same argument from people before, that like we want to keep stuff generic. We didn't have to do this in database X. What if we want to swap it out? And it's like, oh, that needs to be a business-driven decision to actually swap out a major part of your application stack and move it over. It's not something you can just do. Wish it will be. Maybe someday.
I was gonna say, I mean, yeah, ultimately, like, and it's not just that; it's also, things you'll do around query optimization. Certain engines. I think Baron had written something beautifully about locking, and there was also a link about leaky abstractions around, database implementations and how, maybe in MySQL you put this extra, A equals 1, B equals 2, C equals 3 in your where clause, and it gets you like this beautiful index hit. But in Postgres, you'd have to do something completely different to get something similar, and it's just because of the way the various software stacks are implemented. Ultimately, you would make the argument, moving from something like MySQL to Postgres or Oracle to SQL Server is a lot, I'm going to put in quotes, easier than going from MySQL to HBase, for instance, or to Mongo, unless you have some other SQL API on top. But yeah, there's still, I mean, it's definitely a large change, also around how index hints are done, which index hints you use. I mean, I'm pretty sure everyone in here knows of at least one index hint buried somewhere in their application, an application that talks to a relational database, if not more. And it's because they're necessary with edge cases and the way the data happens and around determinism that needs to happen. Which actually, let me dig up that blog post that Baron wrote. It's a very good read for anyone who hasn't read it yet. Please keep talking while I do this.
I think it's rare. Once in '99, I was at a company where we had an Oracle-based application. We converted it out of Sybase SQL Anywhere, and the original design was it was going to be something we'd resell commercially. It was going to be run by cruise lines, and we wanted the cruise lines to be able to pick their own database. So we started on Oracle, but we decided early on, let's keep it vanilla so that if someone wants to use SQL Server, it will work. As soon as I started writing some stored procedures in PL SQL, I quickly convinced management that it was just going to be too much of a task for quality assurance and performance to maintain compatibility on top of multiple databases and have something that's really performant and top-notch. So I've tried it before. It's definitely painful versus when you're in Oracle and you can start writing Oracle-looking SQL and Oracle hints and Oracle stored procedures. I just think it's a matter of how big your company is and what you're trying to accomplish and why.
Yeah, definitely. And so this is the blog post I was just talking about. A few folks were talking about this earlier this week. Baron wrote about MVCC and was talking about MySQL and Postgres with it. I'll put this in the show notes. I encourage everyone to read it. But he also had a link to this law of leaky abstractions thing. And so leaky abstractions is something everyone inherently knows about, but just kind of reading through about it again is pretty eye-opening when you start to think about it and how you deal with it inside of MySQL. But anyways, so back to mixing data and metadata. Was there other stuff that we wanted to kind of go down, other things we wanted to explore?
I think the summary of that is that we all pretty much generally dislike the implementation of triggers, views, and sprocs inside MySQL. TLDR, we don't like it.
And we've got one, feels like one solid suggestion on the table. So that's definitely something. Next time we have Mark on here, we can ask him about it and see if there's any just kind of other work being done around it. Because I know that Mark also has a pretty big dependency on views and all that kind of stuff, especially around performance schema.
Yeah, the schema stuff. Yeah, views aren't so bad usually, right? Like usually, but like the views usually don't end up. The thing about views is, I feel like they don't end up getting used in production a lot. They get used for like some random report you need to give to someone simply or something like that. Like that's generally the use case I see for views. I see far more likely in triggers and sprocs, and specifically sprocs is where I see a lot of the pain happening, is because it's certainly with a certain class of developer, it's a common thing to run the sprocs as the way to develop inside of a database, and with good reason. If you're coming from another database.
Another question about views. Are you only using select on your views, or are you also inserting on views?
I've seen both, but I think 9 times out of 10 it's select only. It's like a nasty select query, and someone just wants to make it so they don't have to remember it or put it into an app somewhere. And I run this once a week, and I hate it, so why don't I just put it in the view?
A bookmark for a query.
Yeah.
But inserts on a view can be quite painful sometimes, because it takes some time before you figure out what it's actually doing and how it's being optimized.
Yeah, I can't even how do you even fix that? Like, does that show up as in a slow log as multiple insert statements, or as an insert into the view and then like magic? Like,
I don't know how it shows up in the slow query log. I would expect it to just show the insert on the view, and then you're looking, and then, oh, wait, it's not a base table.
Well, it sounds like we've got 2 things to talk to Mark about, and I feel bad because we keep I feel like we're talking about him behind his back. But hopefully he's watching at home. Anyway, the metadata part, the way that user accounts and grants are integrated into these objects is painful, and it's difficult to make them compatible, transportable, work them. And then the second thing that seems to be coming up is instrumentation for these is terrible and needs to be made more consistent with the way the rest of the stuff inside MySQL works, being able to look at show process lists and understanding what's going on inside of the sproc. Slow log should behave in a way that allows us to track down what exactly happened as opposed to just guessing at it. So that seems like we got 2 things to talk about, Mark, maybe for next DB Hangups.
Yeah, definitely. All right. Well, are there other things folks want to talk about while we're on this topic, or should we move on to compression?
Let's move on.
All right. Well, let's go down the deep, dark path of compression. So, John, this was something that you actually asked about last time. We have a couple bullet points under it. But if you want to go ahead and kick us off, let's get going.
Absolutely. So InnoDB Compression. InnoDB Compression was released with the InnoDB plugin, I believe, in 5.1. Remember right? Am I remember there? Maybe it was 5.0. Anyway, InnoDB Compression allows you to implement LZMA compression across your database internally and transparently. You use the tables like you normally would, and MySQL on the back, or InnoDB on the back end will compress the pages and uncompress them as needed. Obviously, not that simple, but that's kind of what we hope would happen. Compression's always one of those things that eventually gets talked about in almost every company I've ever been at, mostly because storage is very expensive, and fast storage is really, really expensive. So when you're talking about perhaps reclaiming or gaining a 50% increase in disk storage on a device which may cost similar to a BMW, you tend to actually investigate that. And so my question is that pretty regularly you do compression. What I've seen is that I end up seeing somewhere around like a few hundred % increase in write latency. It is very painful to enable compression inside InnoDB from what I found. And not only that, there seems to be some severe engine stalls related around flushing when enabling compression. And I have seen this recur at multiple companies under multiple applications and multiple workloads. And what I kind of want to ask is, does anyone else on here use InnoDB compression in production? What type of key block size do you use? What type of bottlenecks did you run into, and what did you tune? Did you add more buffer pools to reduce contention on some of the new texts there? Did you what did you do? How did you resolve it? How can we make InnoDB compression better? And as a side note, do you feel InnoDB compression is worth it, or should people be planning on doing compression at the app or client side as opposed to at the database layer?
Yeah, I'm using InnoDB compression in production on 5.5. It's working quite fine, but it's an application with quite a not that much inserts and no selects at all. But there's quite a lot of data in total, so then it really helps. But yeah, it only helps if you're not touching the data at all.
Did you benchmark before and after? Is the SLA, or are the SLAs on those writes pretty tight for you, or is there no SLA? Is it just simply like if it goes in eventually it's fine?
No SLAs. It's just an archive database, because the main database is running on a MySQL cluster. So it's just archiving. And recently they started also to do some selects on it, and it's working fine for now. Compression, decompression takes a bit of time, but eventually, yeah, it's working quite fine. But the database is not that heavy loaded, so
lots of data. Are we talking hundreds of gigabytes? Are we talking multiple terabytes? In that ballpark, right?
I think it's about 500 gigabytes compressed with a key block size of 4.
Oh, with a 4. Wow. Okay. Okay.
Yeah, that's something you really need to be careful about.
So actually, can someone just explain a little bit around key block size and kind of the implications of some of these configuration options in InnoDB compression?
So standard page size in InnoDB is 16K. By reducing the key block size, you tell InnoDB to try and achieve that page size as much as possible by compressing the data, so it doesn't have to page split. I guess that's a gross oversimplification. That's what I'm trying to do. Someone else might have more internal knowledge than I do about it, but it's basically a goal for InnoDB to try to do when doing compression. And so the smaller the key block size, the heavier the compression ratio you get. Generally, your standard is 16K from InnoDB, so you can actually do a 16K page size and compress the data inside and perhaps get some things. But if you go to 8K, 8K block size usually means about a 50% reduction in disk usage across textual data usually. So if you went to 4K, even more, like 75%, or higher, would be a ratio I would expect to see something out of that. So,
I think one of the real tricks to good InnoDB compression performance is you got to know your data. And if you've been at a company long enough, you're a good DBA. Maybe you do. As John explained, you pick your key block size, and let's just pretend everyone starts with a 16K default InnoDB block. So if you say key block size equals 4, which Daniel's using on his system, InnoDB is going to take that 16K block. If it achieves 4-to-1 compression, it's a win. It just puts it to disk. When it doesn't, it has to take that original 16K block, split it in half, and then restart the process. So some of the latency you're talking about, the pain on the CPU is the misses. If I can't get 4-to-1, if 16K compresses to 4 kilobytes plus 1 byte, it missed. It chops it in half, redoes the compression on 2 8K blocks, and goes to disk. So those misses are expensive. The recompress operations. If you know your data, like if you've got data that can do between 3 and 4x compression, set your key block to 8, you'll almost never have a miss for that specific table. It's probably mostly a win, although you will eat a bunch of CPU. I come from Tokutech. We compress all the time. By default, it's always on. I don't think I've ever found a user who wanted to turn it off. I don't ever benchmark with it off. So everything we do in benchmark and test and support, compression's always on, and we spent a lot of time doing that. I give InnoDB a lot of credit because they made a design decision early on that they have to stick to for the foreseeable future, which is on disk fixed block size, which is why you have to pick key block size of something. TokuDB has a flexible before and after. We can start pretty much at any size, and our after size is whatever we compress to, so we never have a miss. But in Inno, I give them credit for taking a design that never intended to have compression and adding compression to it. It's impressive that they're achieving compression. It's like adding anything to a system years after the fact. and making it do something useful and performant for certain use cases is hard on any type of system that's got a rigid design around something like block size.
And so I'd also point out, we were talking about compression success. For people who are curious, the way you measure that is from information schema.inodb_CMP will have that information for you to tell whether or not your pages are getting split or not, and whether or not your compression is working efficiently. And as a follow-up question to you, Tim and Daniel, what type of compression success do you look for? Above 98%, 99%? I mean, what point do you say something needs to change?
I was going to let Daniel take that because TokuDB doesn't ever have a miss. Whatever we compress to is what goes to disk.
Okay.
I like compression misses because that turns people to my technology.
Fair enough. Yeah. So yeah, people just kind of look for whatever, and then
So a couple interesting adds, and then you can go to second, Shlomi. So something that was interesting added to MySQL 5.6, I think it came out of Facebook. The idea and some of the implementation was dynamic padding. So
right.
in 5.6, that whole the challenge is you need to know your data really well, and if you don't know your data really well, taking 16K and making it 4K in Daniel's example, it might be challenging to know that ahead of time what the right key block size is, and key block is fixed, it's not dynamic. So dynamic padding says take the 16K block, try to compress it to 4K. If it's a miss, I've got to split and repeat the process, but learn. For that table, trying to get from 16 to 4 is hard. So the very next time you create a new page in InnoDB, you reserve some slack, a little bit of space in the 16K block, so that compression becomes easier. And the system can learn over time that, okay, on this table, on average, I need to pad out 2 kilobytes of the table to achieve 4-to-1 compression. So you're leaving something on the table, but you're avoiding the misses. The only downside to that implementation, if you think about it, is in memory, it has to actually have the image of the block, the 16K. So the dynamic padding, the one downside to dynamic padding is it's eating up your cache table. So if you give 2K of the block to just spaces that are easily compressible, then that's, for that specific table, 15% of the table in the cache is not helping your cache hit ratio at all. But I think it's a really interesting improvement that they made for the general use case of compression.
Right. I believe there's a variable that pretty much says there's a threshold for adaptive padding, and when the success rate falls below that threshold or hits that threshold, it then enables it on a I thought it was almost an engine basis, but I may have been mistaken by how I read the documentation on that.
So who knows? The way I understand it, when I have compressed InnoDB tables, some of the pages are loaded into memory in compressed formats. So some portion of the buffer pool is reserved to compressed pages, and some pages are then extracted. So how does it go? What percentage of the memory is allocated to compressed, and what isn't? Does anyone know?
I actually thought that it was always uncompressed that went into the buffer pool. Like it had a staging area where it did the decompression and then just stored the full page or the full block inside the buffer pool. I didn't realize there was like a separate allocation of we'll store some of the compressed pages over here and some of the uncompressed over here. That's
I think there is. I need to double check this.
Yeah, it can actually get worse. There's a page that's not hard to find if you do InnoDB compression. Compressed uncompressed buffer pool. It says to minimize I/O and reduce the need to uncompress a page. At times, the buffer pool contains both compressed and uncompressed forms of database pages.
And I don't believe there's separate structures. It's all just one big pool, and it just throws it all in there. So you could easily saturate your buffer pool with useless data or duplicate data.
Compression's hard.
Yeah, or else you could fit more data into your buffer pool. So
right, and if
allowed to put more compressed pages inside.
Yeah, it seems like that could almost be an efficiency gain in certain cases where you could, like, say, for example, you're using large amounts of storage, like sounds like Daniel's doing an archive table. It sounds like it would almost be beneficial if you have a bunch of slow spindles under it to have a purely compressed buffer pool and be able to force it to stay compressed and tell it to just evict. And I think that is part of the behavior, if I remember the page that Jeremy just posted, was that it will actually evict the uncompressed page first, in order to try and preserve the compressed page in the buffer pool.
Sure. And the other thing you can do is if you're running buffered I/O, then your OS cache is going to be nothing but compressed InnoDB pages, giving you an additional kind of cache in front of flash, SSD, spinning disks, whatever you. If you're comfortable with buffered I/O, so from a TokuDB perspective, we have certain users who have data that's 30 to 1 compression, and for those people, if they run buffered I/O, then they've got a nice big cache that sits in front of their real I/O for reads to be served from.
But Tim, regardless of buffered I/O, with TokuDB, it's like the recommendation is to allocate just like half the operating system memory to TokuDB, and just make sure the system, So you force TokuDB to use buffered I/O, right? Or at least you want it to do that.
I personally find for most workloads and all my benchmarking that direct I/O for me provides the most consistent performance. But if I get a user who has a use case with highly compressible data that's really skewed toward lots of reads compared to writes, I would tend to say, hey, if you can put 256 gigs of RAM in there, give us a 64 gig cache, keep 100, 3/4 of your RAM on that server to just hold compressed versions of your data in the OS buffers, and then spindles are fine. Like you're probably not gonna need SSDs for that use case for a while.
So here's a breakdown of my experience with InnoDB tables. Compressed tables, I've been using them. Like John said, they came out like 5.137 as InnoDB plugin, and I've actually used them ever since. And in many cases, I've done the benchmark with or without, and in some cases, it just came as a fact that we're using compressed tables. And I use them a lot, but never below key block size 8. So 8 is like the optimal in my view. Okay, it gives you the 50% space, the space benefit, and it's not too terrible in overhead. Like John said, like to do an alter table into a regular InnoDB or a compressed InnoDB, it's like it could be like 2, 3, 4, 5 times slower into a compressed format. And the further you go into the lower key block sizes, like 4, 2, and 1, the gains in space are not that. You wouldn't always be able to save again 50% and again 50%, and on the other hand, the payment you will have to pay is atrocious, right? It's just unbelievable. You could spend days and days and days and days altering a table that would normally alter within a few hours. Now, what I've noticed is that bootstrapping in a compressed InnoDB table is way slower than bootstrapping a normal InnoDB table. So when you start a MySQL server, it takes a lot more time for the table to get warmed up with compressed InnoDB. But then as it warms up, and of course it depends on your workload, but in those cases where I benchmarked, so okay, it took like maybe 3 hours to warm up as opposed to 1 hour to warm up on an uncompressed table. But then it performed quite nicely. So again, with key block size 8, the gain with I/O was usually worth it. It would actually, yes, the inserts would suffer a bit, and if you're like insert only, then you're going to suffer. But it pays out as you actually do less I/O. And it pays off, even with SSDs. I've been doing this at my previous company. It still pays off. So your mileage may vary. One thing about compression is that it's slower, and yet when you look at the CPUs, they're not like 100% utilized. You do top, and they're going okay. They're 50, 60, 70%. It's not like they're sweating. And it seems to me like there's a serious lock-in issue or whatever. I don't know. But it's definitely much slower, and you don't see the CPUs working hard to make it happen. So
definitely.
Yeah, that was actually the problem that we had. And I mean, for us, CPU is actually a much more scarce resource than disk right now. Like storage disk is getting scarce, but like I/O is completely non-existent. Our worst problems are around locking and contention. And so every time we've tried turning on compression, usually just on a downstream replica and just kind of let it go, replication lag is just all over the place. Like it is significantly more laggy than every other
Right.
replica.
That's Jeff. Sorry, I think you blanked out for a second there. Sorry.
Oh, okay. Yeah, but yeah, just go ahead, John.
It's okay. Are you done, Jeff? All right. I guess me. Okay. So that's exactly what I really wanted to touch on was what Shlomi and Jeff you touched on was that the inefficiency of compression does not seem to have anything to do with the actual compression and decompression of the pages themselves, or if it does, it's part of the process. But the actual compression part is not what's killing it. There's some mutexes and some contention within InnoDB, and it seems like the second you enable compression itself and set the key block size down, that those points of contention become far more exposed. And I see this on the LRU pending flush list a lot, and I see this in some of the buffer pool mutexes. And in 5.5, it was atrocious. It was really, really bad. Buff pool, I think it was one of the scan, I forget which one it was, one of the scan mutexes, but that actually went from, we wouldn't see that pop up, and actually it wasn't like right now, a long time ago. We went from an uncompressed workload where we never even saw that pop up to a compressed workload where the contention on that mutex was so bad it could take down applications. And so that's really what I wanted to talk about with compression is that how did people expose this? Where is the actual problem? And how do we get this solved? Because storage is expensive. It's never been cheap. I don't really care what anybody says. Storage is never cheap. So gaining that type of efficiency and coming close as possible to having a no hit, or at least the bare minimum of hit, would be nice. Like, it shouldn't add multiple hundreds you shouldn't multiply your latency, your 99th percentile latency, just for adding compression. You just shouldn't have to. Do simple file system tests, do simple whatever tests. It doesn't take that long to do a fast compression, advanced use of compression on textual data, and then uncompress it. So where is the bottlenecks in InnoDB? How do we pinpoint them? And how do we get someone to fix this?
I think the majority of it is the missed that forced page splits is a huge part of the problem, and I think Daniel put a link in that I want to talk about in a second, where there's a 5.7 lab feature they're implementing that might be interesting and helpful. What I wonder is every time I speak, when I do webinars, asking people to raise their hands, 99 out of 100, I'm happy to see a couple, Shlomi uses it, but for the most part, when I ask the audience how many people use InnoDB, lots of hands go up. How many people using InnoDB in production use compression? It's 1 or 0. And I wonder is this the chicken and egg where people aren't using it because it's not great, and because people aren't using it, Oracle's not investing in making it better? I mean, is it just getting ignored in InnoDB?
Maybe. Maybe people just don't know about it enough. I mean, honestly, it's kind of one of those features that kind of got buried. It didn't get a lot of fanfare when it was released. And if you don't know it's there, you might not know it. So maybe us talking about it will help shed some more light on it. I know Facebook has produced a lot of patches related to it. At least I remember PerconaConf, it was either last year or the year before it, they did a couple of talks on massive patch sets that they made to the compression system. Part of that was the adaptive padding, which I believe is what we see some sort of derivative of in 5.6. Yeah. But if they had to invest that much time to make it work, and I mean, there's a reason for that. If you use it, that's a lot of money you're leaving on the table if you can use it with minimal hit.
And when you have an application with that many servers, with that much data to draw on, they know their key block sizes, right? Even dynamic padding, I'm sure, is helpful, but I would argue they certainly know for this type of table, for this type of data, this is pretty much what we have to set key block size to never have a miss occur. And I think part of the problem too is everyone has just heard how much compression in InnoDB hurts performance, and maybe they don't even bother trying it because that's the legend, right? The tribal knowledge is that that's going to happen, so I'm afraid to even touch it or raise my hand in a DBA meeting and say, can we try this, because everyone else It's going to, of course you can. It's horrible for performance. It's going to slow everything down. Let's not waste our time. What Daniel pointed out, there's a MySQL Lab 5.7 release that came out in April. Sonny Baines had a blog about it that I think Jeff it'll make it to the show notes. So they're implemented something in the labs called hole punching that we actually tried with TokuDB at one point. Didn't actually end up implementing it, but it goes like this. So in Inno you have a 16K block size, and rather than picking a key block, you enable a feature called hole punching. So InnoDB takes the 16K page, compresses it, and let's say it compresses down to 8K for this specific page. Well, then InnoDB writes the 8K, and the other 8K in the file, it does what you would think a hole punch would do. It punches a hole in the file, so it's not really using that 8K. And then the next time it compresses a different page, it goes down to 12K, and it punches out 4K of that. So it saves you from this miss problem, and it saves you from when you miss, you have to split, and what's your key block size and dynamic padding. The only concern or challenge, the reason we didn't implement this in TokuDB in production is it still is a relatively new feature of some file systems, like XFS and ext4 both have support for it. What's weird about hole punching when you play with it is you have to be careful in Linux. So if you do a DU, it'll show you the size of the file, not counting the hole punches that are punched out. And if you do a tac apparent size, it'll say, here's how big that file really is. Copy, SCP, ls, all these commands either have command line switches to tell you what the real size of the file is. They have modes where if you don't copy the file in the right mode, you'll actually copy it unhole punched, which is, sparse is hole punched and unhole punched is not sparse. So the danger there is you could be over provisioning your file system. You might have gigabytes and gigabytes of files that are very sparse. So in reality, they're not taking much space, but at some point they might, and then you're in a real jam because you guys are more operational DBA-wise. When you thinly provision, you run the risk of really needing the space you've thinly provisioned, and then what do you do to get out of that? The other challenge with hole punching is, I think, from a long-term performance situation, I think the jury's still out on what punching hundreds of thousands of holes in files, tiny little holes, will eventually do to the performance of the file system. So I think it's an interesting idea. We're willing to let InnoDB try it first, and if it works great there, we can certainly implement it in TokuDB. But it's kind of a cool idea, and it's definitely a blog worth reading. And Daniel even commented on the blog when I took a peek at the link he put up there.
So that's actually, I didn't even realize this was something down in the file system layer that you could do, and that's definitely a really big thing to think about, especially if you have these $20,000 solid state cards maybe, and you're just literally throwing dollars for a bunch of empty unallocated space, in quotes. But something else that I was actually curious about is so we had compression is a huge deal, right? And so when we deployed HBase clusters, compression is enabled by default in HBase. It's a chore to disable it. I almost want to say, just because you should have it enabled. And one of the changes they made over some major version releases was going from zlib to Snappy as the library for compressing. And I was curious if it just knows, can you tell InnoDB which compression library to use? Tim, I'd actually be curious to hear, does TokuDB allow you to tell it to use a different compression library, and what kind of semantics are there? Because Snappy, it doesn't compress as tightly as zlib, but it's significantly faster, and so maybe that's could help with the performance problem.
In InnoDB, in the production releases 5.5 and 5.6, it's zlib. I don't know if you can set the level. They picked a nice, appropriate level for that. It looks like in that 5.7 lab release, you have support for zlib and LZ4, which is similar but different than Snappy. It's lighter, much faster at decompression, but does less compression. It's a choice you make and you live with it. In TokuDB, we support zlib, LZMA, and QuickLZ. And it's dynamic. You can change it, and going forward, your data will recompress with the new compression algorithm as things get dirty. I'm actually benchmarking Snappy right now. We had a contributor do a patch to enable Snappy, someone who works for Taobao. And the really cool thing about Snappy is the decompression speed is like an order of magnitude faster than QuickLZ. So what we find is on really fast storage, good SSDs or PCI Flash, decompression is expensive when your I/O is just that quick. So giving up, say, 15 or 20% compression to get back the decompressed time might be worth it. I like having lots of choices. You know, we have an uncompressed option, but I had to fight our engineers to actually get that into the product and have it enabled. And I only use uncompressed in our stuff to be able to see, hey, if I didn't have compression, how big would this workload be on disk? I don't ever run benchmarks or experiments with compression disabled. And then the last thing, the other thing Snappy's good at is giving up. Snappy is good at detecting that something isn't compressible, whereas every other compressor on the market seems to just try and try and try. So if you put an MP3 in a database, Snappy is, I think, pretty early on will just say, no big deal, I'm not going to try to compress it, whereas the other compressors will try and report 0% compression.
Yeah, and that was the thing that we had observed in some of our applications, that we were like packing just kind of arbitrary blob data that we didn't need to do any advanced stuff on. We ultimately just Snappy compressed them, and it's exactly what you said, Tim. Like, it's good at giving up. It, you know, if I were to select data from these fields periodically, sometimes it's just perfectly clean, almost completely clean string representation of the data, and other times it's, you know, the packed binary, and it just depends on how much duplication there is. And for me, Snappy has seemed to be very great. Like, HBase changed the default to Snappy. It used to be LZO or something, I think.
Yeah, the real win on Snappy is the decompression time is phenomenally better than QuickLZ, and the compression ratios are within striking distance, say 10 or 15% apart. And it's got a very favorable license, easy to plug in, you know, all the good stuff that comes with certain libraries.
Yeah. So John is telling me there's some other commentary about DB Hangouts going on, and I haven't been able to keep up with it because I'm trying to write a bunch of notes down right now.
So we had some notes from a channel we have, and it looks like one of the Facebook guys noted that they do have tons of compression patches, but Oracle won't accept them.
Literally thousands of pounds of compression patches.
Yeah, they have tons of patches. Quote, and I quote. I'm not sure if that's metric. I don't know.
Are the tons compressed, though?
What's the key block size on that ton? It could be 2 tons. I think we're... So yes, it sounds like Facebook would like to contribute lots of patches to InnoDB compression, but they are unable to. Hint, hint, Oracle. Work on that, or put it into web scale so we can all start switching to that. Facebook, please. So I think I'll bring this up. I want to see if we can try and get some more people to talk about compression next time, because it's honestly a huge topic for me. Like, the money savings. It's all about money, right? At the end of the day, we're all trying to make money. So, like, the type of efficiencies you can gain from compression is massive. I would love to continue talking about it, and I'm going to go back and try and talk to some people and be like, we need more people to talk about compression.
Yeah, I think it would be great if we talk to Mark, if Sonny Baines could come in here and talk about the sparse files. Also, it sounds like in 5.7, at least in labs, they're talking about InnoDB having 32 and 64K page size. And as a compression nerd and benchmarker, certainly the bigger thing you start with, the easier it is to compress it. 16K is hard to get a lot of compression out of something that's small, but once you hit 32 to 48K, it's much easier to achieve 2-to-1 or 3-to-1 on something that starts larger to make it smaller. And Sonny, I'm sure, would be happy to talk about those ideas in InnoDB as well, if he's willing to come on Hangouts.
More and more if either of them would be fantastic. Tim, can you reach out to them?
Yeah, I'll try. Okay.
Sweet, yeah. Sorry, I'm writing all this down.
And then, Tim, this kind of, I mean, again, this is really where Toku should be. This is Toku's thing. We're in Toku's corner right now. Not to add yet another action item to your list, but do you perhaps want to give a benchmark or show off of TokuDB compression? Because, I mean, that's, when I think TokuDB, that's the workload. It's like if you want to archive or work with, like, ETL-type size data set, where you're doing tons of loading of data into MySQL, and you need it done quick, and then you need to keep the disk space usage low. That's where TokuDB shines, and at least from what I know of it and from what I've used it for. So would you want to talk more about that?
Sure. Yeah. I mean, I could take that corner of a deck that I do and make it wide. Just focus on what's really going on there. Sunny or Mark could do the similar thing for InnoDB. It certainly is something where we try to compete very. It's one of we have 3 tentpole features really in TokuDB: compression, agility, and performance, and keeping performance while compressing. So I think what I like about the Oracle and the InnoDB approach is they are what they are, right? They're not trying to pretend that there aren't downsides and trade-offs to compressing your data in there. But I also like hearing about their ideas for the future and how they plan on working on improving them. Yeah, and I'll reach out to Mark and to see if he and/or Sunny can come on and talk about. And I'm even fascinated hearing about the real history behind. We had this InnoDB, and then we decided, hey, we want to put compression into it, and kind of 0 to 60. Like, what were the ideas? What got shot down? Why are page splits so expensive? What's the mutex contention you were talking about? They're very transparent about how the things internally function over there.
Cool. Well, maybe, Mark, that's on your plate.
I've got to scoot. I got a company meeting, so I will talk to you guys later.
Yep, thanks for coming, Tim. Okay, yeah, we are out of time, but anything else folks want to talk about in the next DB Hang-Ups, which the next one's actually going to be during the Christmas holiday for folks who celebrate Christmas, so I think we're going to punt on the next one being in the middle of December and probably hold out until January. But so far we're going to see if we can get a hold of Sunny and Mark to talk more about compression. We had some quite open questions for Mark around the views and stored routines from today, so we could probably touch on those again. But if there are other things that folks want to kind of dive into more next time. Everyone's being very quiet. Okay, I'll see what I can kind of pull up.
Someone suggested that my crazy talk about active rights for
yeah.
that somebody wanted to get into a nice argument about whether or not that was a sane idea or not. So if we want to talk about engineering, a general engineering of environments, I think all of us can bring a little bit of discussion about how we kind of set up our rights and keep ourselves highly available or whatnot.
Sounds good, yeah. So talking about just kind of how reads and writes are configured in your architecture, and the trade-offs that kind of come with that. And yeah, there was definitely some very lively debate about how Etsy does some of their write patterns.
We do it with macaroni art and hand-knitted sweaters.
Oh, man.
Over yarn.
Something else that I'd like to talk about at some point, and maybe we might not get to this next time, but of data inside the schema and all the aspects around that. It can turn into a very involved discussion. Okay, anything else?
We're good.
Alrighty. Well, thanks for coming today, everybody, and we'll see y'all probably after the new year. So have a good holiday or vacation or whatever you're going to do, or keep working if that's what you're doing too. And yeah.
Cool. Bye, everyone.
Yeah. Bye-bye.